Imagine a wall of water hundreds of feet high rushing towards you at 80 miles per hour. Well, if you lived in the Pacific Northwest 14,000 years ago, that would have been your reality. These are the Missoula floods. Lake Missoula was an ancient glacial lake that covered portions of western Montana during the last glacial maximum between 15,000 and 13,000 years ago. It formed because a finger of the Cordilleran ice sheet dammed the Clark Fork River in what is now the Panhandle of Idaho. At its greatest extent, Lake Missoula was absolutely huge, covering an area roughly 3 times the state of Rhode Island and containing more water than Lake Ontario and Lake Erie combined. However, the coolest thing about Lake Missoula isn't its massive size, but rather the fact that it was the cause of several of the largest floods in Earth's history. You see, when Lake Missoula reached a certain depth, somewhere around 2,000 feet, it overtopped its ice dam and catastrophically drained in what we now know as the Missoula floods. Scientists believe that the process of Lake Missoula filling, overtopping its dam, draining, and then filling again occurred every 30 to 60 years, meaning that there were dozens of Missoula floods over the course of the lake's short lifespan, and every single one of them was absolutely huge. The largest Missoula flood had a peak discharge of 2.7 million cubic meters. For reference, during last month's catastrophic flooding in Kerr County, Texas, the Guadalupe River had a peak discharge of 4,000 cubic meters per second, or roughly 700 times smaller than the Missoula floods. Put another way, each Missoula flood was more than 90 times more powerful than the largest nuclear weapon ever detonated, Tsar Bomba. And finally, each Missoula flood picked up and transported boulders larger than cars hundreds of miles on its way from draining from Montana all the way to the Pacific Ocean. And even though Lake Missoula has been gone for well over 10,000 years, evidence of the Missoula floods is found all over the Pacific Northwest today, particularly in the channeled scablands of eastern Washington, which I'm going to cover in a future video. So be sure to follow for more mountain and geography content.